Hey folks, welcome to my channel Number Pen. So there we have the problem on our screen. Find the derivative of tan inverse of sine x divided by 1 plus cos x with respect to tan inverse of cos x divided by 1 plus sine x, right? So we have two functions u and v. Let's write down what is our u and what is our v. So my u is nothing but tan inverse of sine x divided by 1 plus cos x, right? And then my v is tan inverse of cos x divided by 1 plus sin x. Now, all that I've been asked to find is du by dv, right? I'm going to start off with u and then we will proceed to v. We have a tan inverse, so our thought process has to be if I can reduce the expression inside tan inverse to a tan, right? So the expression that I have inside tan inverse is sine x the whole divided by 1 plus cos x, right? So what is my sine x? My sine x is nothing but 2 times sine of x by 2 into cos of x by 2, right? I know that my sine 2 theta is nothing but 2 times sine theta cos theta, and therefore my sine x is nothing but 2 times sine of x by 2 into cos of x by 2. And similarly, when my cos 2 theta equals cos squared theta minus sine squared theta, my cos x can be written as cos square x by 2 minus sine square x by 2, right? And therefore, I know that I can combine the 1, let me highlight it in green, with the minus sine square x by 2, right? And then add it with cos square x by 2, let me highlight it in yellow, right? So what do I get? My 1 minus sine square x by 2, which is the green expression, is nothing but a cos square x by 2. I add it with the expression in yellow, which is also a cos square x by 2. And therefore, I'm left with a tan inverse of 2 sine x by 2 into cos of x by 2, right? Whole divided by 2 times cos square x by 2, right? I know that my 2 and 2 will get cancelled out, and then I have an opportunity to cancel out one of the cos x by 2 as well, and I'm left with a tan inverse of tan of x by 2, which is nothing but an x by 2, right? So let's write down our u, which we have simplified, which is nothing but x by 2, right? So you see I have reduced my u to an x by 2. Let's jump to our v. V equals tan inverse of cos x by 1 plus sin x, right? Observe this expression, right? And relate it to the first expression that we solved. Our first expression was sin x by 1 plus cos x, right? Where we had to do a little bit of simplification to arrive at tan x by 2. And then my expression now inside v is nothing but cos x by 1 plus sin x. So can I make a substitution that will put it back in the form of sine divided by 1 plus cos so that I can avoid the trigonometric simplification? The answer is yes. What is that substitution that I will have to make? My first expression, cos x, is nothing but sine of pi by 2 minus x, right? And what is my sine x? It is cos of pi by 2 minus x, right? So all that I'm doing is my cos x, I'm writing it in terms of sine, which is nothing but a sine of pi by 2 minus x. So watch it very closely. If you've not been able to follow, please do comment and I'll be happy to help you folks out. And in case you have your doubts, you can still expand the expressions above using the sine of a minus b formula, right? For example, sine of pi by 2 minus cos minus x is nothing but sine pi by 2 cos x minus of cos pi by 2 sine x, right? So what happens to the first expression? It is sine pi by 2 cos x, which is a cos x. The second expression is a 0 because your cos pi by 2 is a 0. Now let's come down to cos of pi by 2 minus x. What is cos of a minus b? It's cos a cos b plus sine a sine b, right? So my cos of pi by 2 into cos x is nothing but 0, and my sine of pi by 2 into sine x is nothing but sine x, right? And that's how we arrive at this particular expression, right? So cos x divided by 1 plus sine x is the same as sine of pi by 2 minus x, the whole divided by 1 plus cos of pi by 2 minus x, right? So this expression, right, and let me highlight it in a different color, turquoise, is very similar to the expression here in yellow, which we established as tan of x by 2, right? And let me highlight it in yellow as well. So instead of x, I have a pi by 2 minus x, right? So wherever I have x by 2, I will have to replace it. So wherever I have x, I will have to replace it by an x by 2 in my final answer, right? So what happens is this is nothing but a tan inverse of tan of, instead of x, I have a pi by 2 minus x now, right? So I have a pi by 2 minus x, the whole divided by 2, right? So this is what I have. So I have a tan inverse of tan of pi by 2 minus x, the whole divided by 2, which is nothing but it's a pi by 4 minus x by 2, right? So let's write down that. All that we have done is the final answer here in the previous step for you, right? Which I've highlighted in yellow again, is just replaced by pi by 2 minus x, right? We have not done anything else. So my final answer is pi by 4 minus x by 2 for v, right? So there I have my u and v. Now I've been asked to find du by dv. So my du by dv is nothing but du by dx, the whole divided by dv by dx, right? So my du by dx is nothing but d by dx of x by 2, which is nothing but a half, right? And then I go down to my dv by dx. I have a pi by 4 minus x by 2. My d by dx of pi by 4 is 0. And then my d by dx of minus x by 2 is nothing but minus of half, right? So let me write that down as well. So I have a half divided by a minus half, which is nothing but a minus 1, right? So the derivative of u with respect to v is minus 1. And there we have our final answer. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.